Hi, I'm Andrew.
Hi, I'm Alicia.
Welcome to the interview. Today we're going to be doing a technical interview. Your first question is about valid parentheses. The question is, given a string containing just the characters, determine if the input string is valid. The input string is valid if the open brackets are closed by the same type of brackets, they're closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. Um, as you can see that the four examples there to help guide you through the uh, test cases at the end. If you have any questions, let me know.
Thank you. Yeah. So again, you just said that given a string S containing these characters, determine if the input string is valid. They must close by the same type of brackets, and open brackets must be closed in the correct order. And every closed bracket has corresponding open bracket of the same type. So with the input this would output true. Okay. Then this is false. This is true. Okay. My constraints are then given an S consists of parentheses only of the curly, square, and regular parentheses. Okay, so given that I'm given a string, I'm gonna go ahead and create a stack that is made of characters, and I'm gonna call this stack parentheses stack. Well, I'm gonna shorten it to para stack. Maybe not that, sorry, stack. And then to iterate through the stack of characters, I will create a for loop. Um, that will iterate through the characters using the letters P. And then this will iterate through the string of S. Hmm. Then I will most likely make sure that these, like the first beginning character, are opening brackets. So to do that, I will have to make sure that with my iterator that I will make sure they're equal to each of the open brackets. And I can do mm, just to make sure I can have that, like they have to be like, no matter where they are, they have to have their closed one with them, like as a pair. So like in example 4, like they can have a separate pair of brackets in between them. That would be a test case. Okay. And then I will be returning whether it's true or false. So yeah, again, I would have a Boolean function, and then pair stack, and then 4. So yeah, let me iterate through here, and then I will be doing it with or if this is equal to the character of this curly bracket. Oops. Um, so, and then if it's equal to any of these, then I will go ahead and push that character to my stack. So go ahead, hit push of this character. So therefore, like if it's an open bracket, then I can go ahead and move it, but I'll do another case where if or else actually, sorry, then it can be, let me think about this. Because I have to get, so I'm trying to find the next close bracket, or even I have to consider whether the stack is empty or not. So in my else case, I'll go ahead and do an if statement inside to see if my stack is empty. Using this, and then if so, I'll return false. Or else if, then I'll go ahead and iterate through again to make sure there's a closing bracket. And with stacks, they are on top, first in, last out. So I will have to make sure that the closing bracket will be on top of the opening bracket. So let me go ahead and again see if there are any characters that are with the closing bracket. And I will also do whether they're on the top of the stack. And they're not equal to the opening bracket. Sorry. And with, if they are equal to any of these test cases, then I will do that they will return false. And then moving forward with that, I will go ahead and otherwise pop the bracket from the stack. And then afterwards, I will then return. One second, let me think about this for a second. Um, and then I will go ahead and return, and I will be returning if the stack is empty. So if the stack is empty, then all the opening brackets have then been paired with their corresponding closing bracket. And then otherwise, if the string, So if the string is valid, still valid, that means there are still more unmatched brackets. So then it would return false. So going off like a test case, then if it were to input an example to the opening and close brackets in corresponding order, or actually let's go off at example 3 where it's an open C bracket and then a closed square bracket. It would then create a stack and then it would iterate through this. It would go through the stack to see if it's an open bracket, then it would push the open bracket into the stack. And then else it would see if the stack is empty, which is not, so it would move on. And then it would see that it is a square bracket and it is at, well, I'm sorry, it's a square closed bracket and not at the, and it is not, and it is at the top and not an open bracket, then it will return false and then it will pop. So it will return the empty stack, but it will also overall return false because there's no paired brackets. Yes, I believe that is all.
I believe that should work. Um, we can move on to the second question if you'd like.
Yes, you can go ahead and move on.
Okay, so for question 2, um, the question is about the maximum depth of a binary tree. It says, given the root of a binary tree, return its maximum depth. Binary tree's maximum depth is the number of nodes along the longest path from the root node down to the furthest leaf node. Um, and it's a one base height tree. So if there's one node, then the height would be 1, not 0.
Okay. Okay. So it's a one based height and I'm looking for the maximum depth. So I would have to iterate through the tree, most likely increasing. Hmm. So the example is like 3, 9, 20, no, 15, 7. Okay. And the output would be 3 because 327. Okay. And my constraints is the number of nodes in the tree is the range from 0 to 10. Okay. Hmm. So I have to find the maximum depth of each side of my left and right side of the tree from the root. So trying to think. Hmm. I think the best way to do this would probably do iterate through each side separately. So I would go ahead and first check if hmm,
Are you going
the
to use recursion or a loop to
I'm
iterate
gonna
through?
iterate through, I'm gonna use recursion. So I think my first step will most likely be just checking if the root is null first. And then if so, then I'll just return, sorry, I'll go ahead and just return 0 just to make sure that the root is not null. And then to go through it, then I will create a variable for the left and right. So the variable would be left depth, and that will be equal to, well, 1, because the base would be 1. And and then I'm gonna add that to, let me see. Have to return its maximum depth, and I will have to return it in 3 or 2. Because I'm using a +1 because no matter what, the maximum depth will always be 1, no matter the amount of nodes. And then to do this, I would then use the function that I'm currently in, and then move the root down, or move it down left to the left. Yes. And then I'll continue doing the same on the right. Then I'm trying to visualize whether it will be easier for me to, every time I move down or I start with one base for either the left depth or the right depth, or when I return the value of the max depth, I add 1 then. I think just thinking about both, I think they both will have the same solution.
One way to think about it is you're moving down each node.
Mhm.
After the base case returns 0, you're going to be at the leaf node. And then at that leaf node, you can return up from that leaf node after the base case.
Okay.
So like after the base case returns 0, then int left depth will equal 1 plus 0 from the leftmost leaf node. And then so all I have to do is return on the way up to get the maximum, or to get the value of that leaf node, and then try to maximize, or try to see which leaf node has the maximum value.
Okay. So I'll go ahead and then do it for when I return the value. So I'll go ahead and return the max. And then I'll do the left step first, and then the right step after, and then I'll add 1 to that. And that should work. I'm gonna go ahead and do it if we're the first example where we have 3, 9, 20, 0, 0, and 15, 7. So it would go ahead and go through the right, which is 1, 1, 3. It would compare the left, which would be 1, 2. Sorry, give me a second.
It's okay.
So comparing it to the left, it would have, it would iterate the, oh my gosh, I don't know why. Give me 1 second. Sorry, I'm trying to think about this.
Would you like me to walk through it with you?
Um, yes, that'd be
Okay.
that'd be great. Yes.
So when we first call the function, it will start with the root, which is not equal to null pointer because, or if it is, it's zero, like off the bat. And then
Mm-hmm.
we'll start calling left depth. Then we'll
Mm-hmm.
we'll start calling max depth with the left root from the node we just passed in.
Mm-hmm.
So this will move in the example one, it'll move from 3 to 9 to the
Mm-hmm.
left, which is null pointer.
Gotcha.
And then in the code that you made, it will return zero to the it will return 0 to 9 when we're in the 9 call still. And then after it returns zero, left depth will equal zero, and then it'll call right depth or max depth to the right. And then this will also go point to null pointer. So it will turn 0 to right depth. So then now we're in the 9 node, and we're returning the maximum between the two plus 1. So it will be the maximum of 0 and 0 plus 1 will be 1. So now we return 1 to node 3. So now we're in node 3 with left depth is equal to 1. And then after that, we call max depth for the right node. And the same process kind of happens where it will go right first and then left. And then after 15 returns both no pointers, 15 will be 0. And then it'll go back to 20 and will return 1 height for the left node of 20. And then after it gets the left node, it will go right and get the height for the right node, which will be 0, and then add 1, so it'll be 1. And then for 20, it'll say the maximum between the left and the right nodes is 1. And then we'll add 1 to that as well and return it to 3. And then finally, we're back at 3 from the code that you wrote. And we're returning the maximum of the left depth, which was 1 from the 9. And then the right depth, which was 20, or which is, sorry, 2 from the 20. And
Mm-hmm.
then from that final call, we call the maximum between the two, which is max of 1 and 2, which is 2. And then we add 1 again, and it will return 3, which is the correct answer for the recursion solution.
Gotcha.
So I believe you are correct.
Thank you.
Yeah. Okay. Let me look at the questions real quick. What went well? So I think that you walked through your thought process really well. Like I was understanding where you were in when you were solving the solutions.
Mhm.
Um, One thing you can improve on is asking more questions. Like if you're stuck or having a hard time getting the next little step of the solution, you can ask. And
Mhm.
I'm sure that they will love to give you little hints every now and then. Um, some strengths again, I knew where you were in your thought process, which was really nice for me because I could see um where if you did need help, I was able to hear what you were stuck on and what you knew like right away. So that was really nice. I think that if you just practice more, like everyone could use more practice. Um, you'll be really good, but like really well on the questions. But I think that you did really well on how you approach the questions. Like you walk through each example first, and then at the end for tests, you'd like walk through the test cases, which was nice to make sure your program ran like correctly. So I think you did really well. It's just a little bit of practice, and then it'll be great. I think that's. Oh, we can walk through your first question.
Okay.
Um, so like we can just do example four, where it's parentheses bracket bracket or bar
Hmm.
parentheses bar bar parentheses. Um, so the first character will be parentheses, which will get pushed onto the stack in the loop, and then the second one will be a bar, which will also be pushed on, and then the third one will be a closed bar, which will go into the else case, and then the stack is not empty, so it will not return false. Um, and then so key is equal to closed bar, and the top is equal to open bar. So it will not trigger this case, and it will pop the bar off. And the same thing will happen with the parentheses, where it will pop the parentheses off, and then it will return the stack as true for being empty. Um, yeah, and then I think for the false one as well, the parentheses in the bar, it'll push the parentheses on, and then it'll see that the bar is not equal to um an open bar in the stack, so it will return false right away. So I think this is also good.
Some.
Cool. So if do you have any questions or thoughts or feedback or
Um, I really like the quality of the questions you picked. I feel like um it really tested my knowledge in different areas that still correlate with each other and like overall just feel like it challenged me and I really appreciate that. So I feel like both of the questions that you gave to me today were very good. Um, and I felt like your explanations with working through my code and shows that like not only does it work, but you understand it very well, which is very appreciated and helpful.
all right, cool. I think that concludes our technical interview. Um, have a wonderful day.
Thanks, you too.